So yesterday we did a little bit of exploring with radian measurement. We watched a video that kind of explained or kind of gave us some background history of the need for radian measurement. The idea of a radian measurement is it standardizes it. It's not based on 360 degrees, which developed out of the rotation through a full calendar year, is how that 360 came about, which on any other planet doesn't really make as much sense anymore. So then we looked at what could we do to make it more standard. So the first investigation that we looked at is if we drew a unit circle, or a circle that had a radius of 1, and we looked at the circumference of that circle as being 2 pi radiuses, which in this case would just be 2 pi, what I get is that one full rotation is equal to 2 pi. And we're going to call them 2 pi radians. A radian in itself is a proportional measurement. So the definition of a radian is if I take this radius here and I translate that length into an arc, and then I create this wedge so that all three measurements are the same. I'm basically, in a sense, drawing not an equilateral triangle because I've got a curved, but it's close to being an equilateral shape. What I end up with is I end up with an angle measurement that is 1 radian. And as I go around the circle, I get 2 pi of those radians. So if I measured it out, 2 pi would be, what's 2 times pi? Approximately. 6 point something. And this would bring me, I'd have like almost 6 and a little bit of these wedges if I was to measure it out with string. So if we look, the radian measure of an angle is the length of the arc that forms the angle, or in other words, arc length divided by the length of the radius. So this is the picture that shows that down here. Where the radiuses are the same, this would be considered 1 radian measure. The following page just goes through all of those conversions. Get to the following page. Here we go. Really, what I want you to know is that 1 full rotation is 2 pi. And I can get that 2 pi by going back to my circumference and using a unit circle. So in terms of degrees, 2 pi is equivalent to 360 degrees. If I go halfway around the circle, which is 180 degrees, I would be going halfway around this 2 pi, which would give me just pi. This part in here where it says to multiply by pi over 180 or multiply by 180 over pi, don't try to memorize that. Go by a proportion. Degrees to radians. I know that I have 180 degrees to pi radians. And then I can finish off the proportion with whatever it is that I'm given. That is going to be the easiest way than trying to remember, is the pi supposed to be on the top or is it supposed to be on the bottom? Because that tends to be a confusing thing. There's only so many things that we can hold on to get us to the end of the course, especially if we're not using it all the time. I don't want you to get bogged down on something this trivial, especially if you can just start from that point. Okay? We can use the abbreviation rad for radians, or we don't use a unit at all. So if I say that angle theta equals 5, and I don't put a degree symbol, the implication is that it's 5 radians. wanted it to be 5 degrees, I would have to use the little degree symbol, which is why for the last 2-3 years, I've been emphasizing you need to put the degree symbol. The angle has to be in degrees because we do measure angles in other units. There's a third unit called gradient measure, that's university math. It's not used as often, but it is another way of measuring an angle, which is why your calculators, those scientific calculators, you had to make sure you were in degree when you were in junior high. And now that we're dealing with this chapter, we can go back and forth in our calculator between a degree mode and a radian mode. Okay? Fun stuff. So if we want to convert from degrees to radians and leaving the answers as exact as possible, what I can do is I can set this up as a proportion. 260 degrees is to some radian measure as 180 degrees is to pi. So how would I solve this proportion? What's my technique?
Cross multiply.
Cross multiply. So when I cross multiply, what do I get?
$270 pi equals 180x.
Oops, I guess I should put that. Okay, so 270 pi equals 180r. So then divide both sides by
180.
So then I've got 270 pi over 180. And when it says in exact terms of pi, look at the 270 over 180 and simplify it. Can I write that in a simpler fraction? 3 halves. So I write the 270 over 180 as 3 halves, and I keep the pi as a constant value. So I get 3 pi over 2. So if I do the same thing, or I will let you actually do the same thing for 315 degrees and see what you get. Okay, so if I take my 315, I put it over r, and I have 180 degrees, over pi. So when I cross multiply, I will get 315 pi over 180 equals r. And then if I reduce 315 over 180, what does that give me as a fraction?
7 4.
So this would be 7 pi 4. So question number 2, we can do the exact same way, only now we're going to actually evaluate it. So instead of leaving it as 7 pi over 4, I'm going to do the calculation 7 times pi divided by 4 and get an answer to the nearest 10. So again, I'm going to give you a couple of minutes. I want you to do questions A and B. Okay.
One more thing.
Oh, sorry.
I'm sorry.
Okay. If we go from degrees to radians, only this time we are just expressing our answer to the nearest tenth. So again, we get 70 over r equals 180 over pi. So then r would equal 70 times pi over 180, which to 1 decimal point is equal to what?
1.2.
And my units would be 1.2,
Nothing.
nothing, or
No.
1.2 rad.
Would do nothing.
Okay? So then 205 would be how many radians?
3.6.
Good. I'm not going to go through all the calculations because you guys are doing well. So if I want to convert now from radians to degrees, this one does get a little bit more complex because I'm dealing with fractions and then more fractions. But if I let this still be a proportion, oh, sorry, not over r, it would be over what this time?
Degree.
D for degree. And then that would be equal to pi over 180. So when I cross multiply, I get 180 pi over 4. So 180 divided by 4. So now I get 45 pi equals pi times d. What's going to happen to the 2 pi's?
Cancel out.
Cancel out, so I get 45 degrees. So I'm going to give you a couple of minutes to do the next 3. Okay, so this negative 7 pi over 3, again, if we did our proportions, where d would equal pi over 180. So I would take 180 and multiply it by negative 7 pi, and it would be all over 3, and that would be equal to pi times my degree. So 180 times negative 7 divided by 3. What would that equal?
Negative 420.
So I get negative 420 times pi equals pi times d. The pi's cancel, and I get negative 420 degrees. With question number 4, it is a little bit different because I'm not given that pi value, but I can still do this the exact same way. Over d is equal to, I'm going to put it over on this side, pi over 180. So I get 180 times 1.57, and if I divide that by pi, I'm going to get my degrees. So how many degrees do I get with 1.57 rads?
90.
And if I had to make it to the nearest tenth, be 90.0. And then again with the last one, this is over d equals pi over 180. So I cross multiply 180 times negative 1.4 divided by pi will equal d. And what do I get?
Negative 80.2 degrees.
Okay. So how do we feel about going from radians to degrees, converting back and forth? Good? Okay. So those terms that we talked about in the first section, the coterminal, the reference angle, the rotational angle, or the principal angle, they still have the same meaning when I'm dealing with radians. Only now, instead of talking about a coterminal angle to a 45-degree angle, it's now coterminal to something like a pi over 4. Okay? So coterminal angles are angles that have that same terminal arm. So if I draw my angle, this is my terminal arm. That's one angle. A coterminal angle, I could go around one complete rotation and get back to the beginning. In degrees, one complete rotation was how much? 360. But I'm not dealing in degrees, I'm dealing with radians. So one complete rotation in radians is how much? 2 pi. So that's what would separate my coterminal angles. Principal angle is the smallest positive rotational angle. In degrees, it was that angle that was anywhere from 0 to 360 degrees. Again, if I'm talking radians, 0 degrees is 0 radians. 360 degrees becomes 2 pi radians. So my principal angles are going to be anywhere from 0 to 2 pi. And then that reference angle is the angle that I get when I drop the terminal arm to the x-axis. And what I'm doing is I'm creating an acute triangle. So in the last section we did look at, in quadrant 1, the reference angle is the same as the rotational angle. In quadrant 2, the rotational angle is 180 minus the reference. Quadrant 3, it's 180 plus the reference. And in quadrant 4, it's 360 degrees minus the reference. the relationship is still the same. It's the numbers that change. So instead of 180 degrees, how many radians am I talking about? Pi. So this would be pi radians minus the reference angle. In quadrant 3, I'd have pi radians plus the reference angle. And then in quadrant 4, instead of 360, it would be 2 pi radians minus that reference angle. And quadrant 1 would be the same. Whatever the reference angle is, the rotational angle would be the exact same. So the next couple of questions look at drawing these reference angles. So what I want you to do is I want you to treat these kind of as a circle. Well, treat them as a circle, which is why I gave you those circle fraction wedges. And we know that this is 0 radians. And when I go halfway around, how many radians do I have? Pi. And then when I get back to the beginning, I would have 2 pi. So this could be 0 or 2 pi. Okay. What fraction is this measurement up here? How far around the circle did I go? Or how far around here did I go?
Halfway.
Halfway. So this point here would be half of that. So all of these divisions are like a half. So I have 1/2, 1 whole, and then now I'm at 1.5, which as a fraction would be 3 pi over 2. And then I have 4 halves, which is the same as 2 pi. So now if I have this radian measure of 3 pi over 4, think of this as being from 0 to 1. What am I going to split that up into?
Quarters.
Into quarters. 1 quarter, 2 quarters, 3 quarters, 4. There's my 1 whole. And then 5 quarters, 6 quarters, 7 quarters, and then my 2 whole, or my 8 quarters. So if I want to go 3 quarters, or 3 pi over 4, this becomes my measurement. So if I wanted to have a, so this is the angle in standard position. The principal angle is that positive angle. So the principal angle would be the same thing. And then those coterminal angles I get by adding or subtracting multiples of 2 pi. So I take my given angle and I add a multiple of 2 pi. How many quarters are there in 2 pi?
8.
8. So instead of writing 2 pi, I could write 8 pi over 4. Because I need common denominators to add my fractions. So 3 pi plus 8 pi equals
11 pi.
11 pi. So that's a positive coterminal angle. I could then add another multiple of pi. Or sorry, another 2 pi. So I could get 19 pi over 4 and just keep going on and on. Or I could subtract. Three pi minus 8 pi over 4. What would I get? Negative 5 pi over 4. Which I could also count going this way. Negative 1, negative 2, negative 3, negative 4, negative 5. And then it says, write an expression involving the principal angles that would represent all the angles that are coterminal with this given one. So the principal angle is my 3 pi over 4. And to get my coterminal angles, I add or subtract multiples of 2 pi. So instead of it being 360 degrees n, it's 2 pi n. But what does n have to be? An integer. Okay? Okay, so let's look at B. Again, we think of this as going from 0 to 1 whole pi. What do I split that up into? Into thirds. I look at the denominator and I'm going to split it into that. So 1, 2, 3, 4, 5, 6. What does negative tell me to do? Go clockwise. And it's, so each of these now represents a pi over 3. So negative pi over 3 would be going clockwise like that. So that's my angle theta. The principal angle starts at that x-axis and goes in the counterclockwise direction. So what would that be equal to? But when we write it, it would be 5 pi over 3. Okay, give me a coterminal angle for 5 pi over 3, a positive one. What would I add to that?
6 pi over 3.
6 pi over 3, because 6 pi over 3 equals 2 pi, which is 1 rotation. So what do I get? 11 pi over 3, good, Evan. Okay, what do I do for my negative one? Because I already have a negative angle given. And that negative angle I would get if I went 5 pi over 3 minus 6 pi over 3. There's my negative pi over 3, but I already have that one. So how would I get another one?
No, it is 6 pi over 3 again.
Okay. And what would I get?
-7 pi over 3.
Okay. Look at question 6a. Sketch it and see if you can determine what the reference angle would be, given what we know about reference angles. 4 pi over 3. I find it easier to sketch these than to rely on the chart, because if I can't remember that chart, then I'm stuck. So if I sketch 4 pi over 3, it means 1, 2, 3, 4, 5, 6. There's my divisions. 4 pi over 3 puts me right down here. That's my rotational angle. My reference angle becomes this. What is this measurement? Pi over 3. Each of these were a division of pi over 3. So my reference angle would be pi over 3. So let's do it again. What is 5 pi over 4? What does the 4 tell me? So if I split this into fourths, 1, 2, 3, 4, 5, 6, 7, 8. Negative 5 pi over 4, what would I do? Where would I find it?
Going clockwise.
Going clockwise. 1, 2, 3, 4, 5. So this is the rotational angle. So then the reference angle, I drop it. What does this represent?
Pi over 4.
Pi over 4. You want to try the last one on your own? So 23 pi over 6. What do you notice when you start to sketch this angle?
You're gonna have to go around once.
You're going to have to go around more than once. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So this is where I'm going to end up. But to get to 23, I had to go around almost 2 times. Where am I losing you, Rachel?
I'm just confused on like your wedges, how you drew them.
6. So I divided from here to here into 6 pieces. So if from here to here is in 6, that means here to here would have to be 3. Because the 3 and 3 would give me 6. So the 6 isn't all the way around. The 6 is what I divide the half in, because the half is that whole pi. So then my reference angle would be this little piece right here. How much is that little piece worth?
Pi over 6.
Pi over 6. Okay, I'm going to push through and do the next part on arc length, and then I'll give you the questions to work on. That'll be for all of them. Now, at the beginning of this section, when we were looking at radian measure, we defined a radian as being the length of the arc divided by the radius. And so we said that 1 radian was when the arc length and the radius were the same. So if I change some of my symbols, and instead of letting this be 1 radian, I say theta radians, where theta is my angle, is the arc length over r, I can rearrange the formula to solve for arc length. Because the chances of me in this circle at the beginning of the section knowing what this length is not as likely. I would be more likely to know the radius and the angle that I've drawn than I would to know what that arc length, because it's a curved line. It's very hard to measure a curved line when all of our rulers are straight. Okay? So I can rearrange the formula to solve for arc length. The key is this arc length formula was derived by the fact that we were talking about radians. So when we use this formula, this angle must be in radians. And the most common type of question to test this outcome is to give you a question where the angle measurement is given to you in degrees. Because if you don't convert it into radians, you will get the question wrong. And the distractor, meaning the choice for the degree measurement, will be one of the choices for you to choose from. So if you think back to how did we develop radians, we talked about the radius between the arc length, or the arc length and the radius. That's how I got my radian measure. So when I rearrange this formula, this angle has to be my radian measurement. So we've got 3 problems to work on. The first one, a pendulum. If you guys are in physics class, you know what pendulums are. You've used them. Yay. 30 centimeters long, and it swings through an arc of 45 centimeters. What angle does it swing through? So if I have this pendulum, that's the pendulum. That's the 30 centimeters. And it swings through an arc that is 45 centimeters long. So the question is, what is the angle? You are given the arc length formula on your formula sheet. A equals r theta. What variables do I have values for?
A and R.
A and R. What's A?
45.
And what's R?
30.
Rewrite that. So 45 would equal 30 theta. And so what would theta equal? Okay.
Three halves.
3 halves. So theta would equal 3 halves, or 1.5 what?
Radians.
Radians. And then to convert that into degrees, I can use my proportional reasoning. 1.5 radians is to degrees, as pi radians is to 180. So then my degree would be 1.5 times 180 divided by pi. When the question says to the nearest tenth, I know that I can round, so I can use pi as an actual value and not just as a constant variable. So what do I get? Good. Okay, let's look at number 8. Calculate arc length to the nearest tenth of the meter of a sector of a circle that has a diameter of 9.2 meters if the sector angle is 150 degrees. So if I was to picture this, I would have a circle, diameter is 9.2. And I have a sector of a circle that has a measurement of 150 degrees. So there's my sector. And this is what I want to know, is what this arc length is. So in my formula, A equals r theta. What information do I know at this point?
You know your R.
How do I know my r?
Half your diameter.
Half my diameter. So r is 9.2 divided in half, which is, okay. What about theta?
You have it in degrees, but you need to change it to radians.
So how do I change it into radians?
180 over pi equals 150 over x.
Okay. So I get 150 pi over 180. The 150 and the 180 I can reduce. They're both divisible by 30, so I get 5 pi over 6, which gives me some decimal number, but I can use that decimal number and then I multiply it by 4.6 to give me, what'd you get, Hannah? Okay. So to the nearest tenth, it would be 12.0. Okay? So let's look at class example number 9. I have a circle with center C and a minor arc AB measuring 15.2 centimeters. So the minor arc is the shorter of the two. Okay? If angle ABC is equal to angle BAC and they're both pi over 6 radians, so ABC is pi over 6, BAC is pi over 6, the question is, what is the length of the radius? So I have arc length. I need to find radius, which means there should be some way to calculate the angle measurement. And the angle measurement has to be this one, angle C. How do I calculate angle C?
Subtract pi minus pi over 6 twice.
Why am I subtracting but with pi?
Pi is 180 degrees and triangles all equal to 80.
Does that make sense? So a triangle is 180 degrees, which in radian measure is pi. So this pi here, is that the same as 6 pi over 6? So if I write it as 6 pi over 6 and I start subtracting 2 pi's over 6, what do I get?
4 pi over 6 or 2 pi over 3.
So 4 pi over 6, which becomes 2 pi over 3. So how do I get rid of the dividing by 3? Multiply by 3. And then I get 2 pi r, and then divide by 2 pi. So 3 times 15.2 divided by 2 pi. Make sure that your 2 pi is in brackets, because it has to do that calculation first. And even your 3 times 15.2 needs to be in its own set of brackets. What do you get? What did you get, Rachel? 7.3. Okay. So the questions that I'm going to give you are right from the beginning. So the first 3 questions are practice questions on converting from degrees to radians. No, sorry. Yes, from degrees to radians. The next group of 3, which is 5B, C, 6, B, F, and 7, are the coterminal and the reference angle stuff. And then 12 to 17